In this video, we're going to talk about the derivative rules for the big six trig functions. And of course, of those six, the two big ones that are really important are the sine function and the cosine function. This d over dx is our notation for derivative. So what we're saying here is the derivative of the sine function equals blank. And we're going to fill that in a few minutes. And so hopefully at the end of the video we're going to be able to derive sine, cosine, as well as tangent, cosecant, secant, and cotangent. We're going to work through the derivative of sine kind of through a graphical, intuitive sense. And the number one thing I want you to remember as we go through this is a derivative measures slope. A derivative measures slope. More specifically, instantaneous slope at a specific point. So as we go through here, for instance, if I was to start at pi over 2, the tangent line at pi over 2 would be horizontal, and therefore the slope would be 0. So the derivative has a value of 0. And the same could be said at 3 pi over 2. The tangent line again is horizontal, and the derivative value is 0. Now let's back up here and say, let's take a look at x equals 0. The tangent line appears to have a slope of 1, and in fact it does. And so the derivative has a value of 1. At pi, the tangent line has a slope of negative 1. So the derivative has a value of negative 1. At 2 pi, the tangent line has a slope of 1 again, and so the derivative has a value of 1. Now if you take a look at the 5 points you've just plotted, you might start to recognize what they're forming. And as I connect these points, what curve do you see? Yeah, we just developed the cosine curve. And in a loose sense, we just try to prove to ourselves that the derivative of sine is equal to cosine. So let's jot that down in our notebook. The derivative of sine x is equal to cosine x. Alright, let's work through a similar process to try to figure out what the derivative of cosine might be. Right off the bat here, at x equals 0, it's a turning point or a relative max on the cosine function, so the tangent line is horizontal and therefore the derivative has a value of 0. The same could be true at pi, the derivative has a value of 0, and the same could be said at 2 pi. The tangent line is horizontal and therefore the derivative has a value of 0. At pi over 2, something interesting happens. The slope is negative 1. And, oops, I just saw a typo. That should be a 2 right there, 3 pi over 2. The tangent line has a slope of 1. Now, what curve did we just create? Did we just create the sine curve? Not quite. Go ahead and connect these dots. Concave up, concave down. It kind of looks like the sine curve, but it's flipped upside down. It's reflected over the x-axis, and in fact, this is negative sine of x because it got reflected. So basically what we've just proven here is that the derivative of the cosine function is equal to negative sine x. Now the other 4 trig functions aren't as intuitive just by looking at the graph, so we're just going to kind of jump the gun and give you those rules. And so we're going to put these in a really special spot in our notebook. So a quick recap of the two we just did. The derivative of sine equals cosine, and the derivative of cosine equals negative sine. Make sure we got that negative in there. Now the derivative of tangent is a fun one. Derivative of tangent is secant squared of x. Now we're going to derive the reciprocal functions. Okay, the reciprocal of sine is cosecant, and his derivative is negative cosecant x cotangent x. Yeah, that one's kind of ugly. Slide that up. Let's see, the reciprocal of cosine is secant, and the derivative of secant is secant x times the tangent of x. Okay, as you're writing these, don't forget your x's or if you were using thetas, you could certainly use thetas. But these expressions without a variable in them become meaningless. And the last one is the derivative of cotangent, which is going to be negative cosecant squared. Now, I'll give you a few tricks to help you remember these, or at least one big one. If you look at the 6 trig functions, okay, there's 3 of them that start with the letter C, isn't there? Okay, cosine starts with the letter C, cosecant starts with the letter C, cotangent starts with the letter C. Now, their derivatives have something in common. Their derivatives are all negative. So, the way I always remember it is if the trig function starts with the letter C, then I know his derivative is going to be a negative something at least as a starter to get you going. And conversely, if the trig function doesn't start with the letter C, then the derivative is going to be a positive something. We're going to try to look at 2 quick examples here. Example number 1, let's say I gave you a function such as 2 sine of x. Okay, the derivative would simply be 2 cosine of x. So basically you're saying, okay, here's the function, his derivative is cosine, and the coefficient that I attach to that sine function just attaches itself to the derivative. So it really doesn't make our job any harder. In fact, let's do another one like that. If I said f of x equals 7 times the tangent of x, then simply the derivative would be 7 times whatever the derivative of tangent itself is, which if you look at your notebook is secant squared. Or they may attach some kind of polynomial term to it, and maybe f of x equals x cubed plus cosine of x. In this case, the derivative function would be 3x squared minus the sine of x. And again, getting that minus sign in there is big. The derivative of cosine is negative sine. So I hope that helps. Hopefully today's sheet's not too hard. The hardest thing is just going to be, eventually at some point by September is memorizing those 6 rules.